The North American power grid, as you probably have heard many times, is the single largest machine ever built by man. And this is said because the transmission lines run from Mexico in the south right up to Canada in the north. And the transmission lines are over 150,000 miles. So when we have different sources of energy connected to the electric power grid, we can have all the energy come in, but if the control is not an intelligent and a smart one, energy can be wasted. And for example, one example is that you have a lot of wind speed variation, which means all of a sudden you'll have a lot of wind energy, and then all of a sudden you have less. So your control must be able to adapt to these variations and make the maximum utilization of what is available. Get the best out of what you have, the limited resources. So this is where the intelligent control comes in. So once we have intelligent control, we can integrate all forms of energy, and the control, the intelligent algorithms, brain-like inspired, will make the best utilization of what is available, and therefore more efficiency and more emission reductions and things like that. Where we are collaborating with a neuroscientist at Georgia Tech who works with the living brains, and this is brains of rats. So we want to connect a real-time simulation of an electric power grid to this living brain, and the task for the living brain is to learn the power system dynamics, and after learning the dynamics, to see whether it can come up with optimal control signals. Once we're able to get a brain to learn that, then the task for us is to figure out how did the brain learn, and to come up with mathematical formulations so that one can have an algorithm or a recipe which is more biologically inspired that can handle large-scale problems on the power network.